Hello students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous class. In this session, we will study the basic fundamental of this chapter and we will do some basic example also. So students, let's start with the chapter itself.
Students, after complex number, we are going to study quadratic equation. First of all, here we are going to study definition of the quadratic equation. An equation of the form ax square plus bx plus c is equal to 0, where a is not equal to 0 and abc are the complex number is called a quadratic equation. The numbers abc are called the coefficients of the quadratic equation. A root of the quadratic equation is a number alpha, such that a alpha square plus b alpha plus c is equal to 0. You can write it f alpha is equal to 0 if equation is represented as fx is equal to 0. The equation fx is equal to 0 means it is ax square plus bx plus c is equal to 0. Let's some example of a quadratic equation here. Example number 1. 2x square plus 3x plus 4 is equal to 0. Here ABC are the real number. And we can write that 2 plus iota times x square plus 3 iota x minus 4 is equal to 0. Here coefficients may be complex number. This is the basic definition of the quadratic equation. Students, roots of the quadratic equation can be obtained by x equal to minus b plus minus within a square root b square minus 4ac upon 2a. This is called 𝕍𝕀𝔻𝔼𝕆 formula. And the quantity b square minus 4ac is represented as d and it is known as discriminant of the equation. How this equation can be obtained or this formula can be obtained? Let ax square plus bx plus c is equal to 0. It is the quadratic equation. Now we are going to divide this equation by a. We can write like this: x square plus b upon a times x plus c upon a is equal to 0. Now we are going to make a perfect square here. Means it is x square plus b upon a times x plus. Now we are going to add a term b upon 2a whole square. Now subtract it. It is the b upon 2a whole square and remaining portion is plus c upon a is equal to 0. Up to this part, this is a perfect square. Square of x plus b upon 2a whole square. And now it is equal to b square upon 4a square minus c upon a. We are going to simplify it. Taking 4a square as a LCM, it will equal to b square minus 4ac. Now we can write x plus b upon 2a is equal to, within a square root, means plus minus sign is here, it is b square minus 4ac upon 4a square. Now simplify it. X is equal to minus b plus minus within a square root b square minus 4ac upon 2a, and this is the discriminant. And by taking plus and minus sign, we can find both the roots. For plus sign, let root is alpha, and for minus sign, let root is beta. Students, quadratic equation can be categorized as real quadratic equation if ABC are the real and it is given that a is not equal to 0, then quadratic equation is called the real quadratic equation. What is the meaning of monic quadratic equation? If the coefficient of x square be unity, means 1, then the quadratic equation is called monic quadratic equation. For example, x square plus 3x plus 4 is equal to 0 is the monic quadratic equation. Students, here are results related to the quadratic equation. First, nature of roots of quadratic equation: ax square plus bx plus c is equal to 0, where a is not equal to 0. Point A is here, the quadratic equation has real and equal roots. Actually, the roots of quadratic equations are x equal to minus b plus minus within a root d upon 2a. If d is equal to 0, then both the roots means alpha and beta is equal to minus b upon 2a. Because this d is 0, that's why there is no discrimination, or we are not going to take the plus and minus sign, because this system is 0. So roots are equal and real. Then condition is, if roots are equal and real, d is equal to 0. If roots are distinct and real, when the roots are distinct, if there is a one root taking plus sign like this, minus b plus root d upon 2a, and other root is minus b minus root d upon 2a, then we can say roots are distinct, and it is possible only when if d is positive. That's why we can say that if roots are real and distinct, then d is greater than 0. And if d is less than 0, then within a square root, negative number does not exist. That's why we can say roots are complex or imaginary roots. The quadratic equation has complex roots with the non-zero imaginary parts if and only if d is less than 0 and ABC are the real number. This is the nature of roots of quadratic equation. I am going to repeat it. First, roots are real and equal if d is equal to 0. Roots are real and distinct if d is greater than 0. And roots are imaginary if d is less than 0. Students, what is the condition for rational roots? The quadratic equation has rational roots if d is a perfect square. What is the meaning of this? If d is a perfect square, then what will happen? There will be no radical sign here. Means if d is perfect square, then you can write roots of the form minus b plus minus, you can say it is alpha upon 2, means both roots are rational, means of the form p by q. So the fundamental condition is here, if d is a perfect square, then roots are rational. Students, third condition is here, condition for integral roots. What is the meaning of integral roots? Means roots are integer. If a is equal to 1 and bc are integers and the roots of the quadratic equation are rational, then roots must be integers. This is one of the most important concepts which you have to keep in mind. Students, what is the sum, product and difference of our roots? As we know, roots are obtained by the 𝕍𝀍𝔻𝔻 formula. It is minus b plus minus root d upon 2a. One root is alpha and other root is beta. Let alpha is equal to minus b plus root d upon 2a and beta is equal to minus b minus root d upon 2a. Then what is the value of alpha plus beta? The value of alpha plus beta is, we are going to add these two systems. It will be minus 2b upon 2a and it is equal to minus b upon a. What is the value of product of the roots? The product of the roots is here. It is 4a square in denominator and here is a minus b into a plus b, means it is a square minus b square. What is the value of b square? It is d. And what is the value of d? It is b square minus 4ac. So we are going to write b square minus, it is b square minus 4ac upon 4a square. Now simplify it. It is 4ac upon 4a square and it is equal to c upon a. So the product of root is c upon a. And we can find difference of the root. How we can find the difference? As we know, alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. What is the value of alpha plus beta whole square? It is minus b by a, means it will be b square upon a square minus 4c upon a. Now simplify it. It is a square b square minus 4ac. b square minus 4ac is d upon a square. Now the value of alpha minus beta mod is equal to square root of d upon a mod. If alpha and beta are the real, means this is the sum, this is the product, and this is the difference of the roots. Students, some concept you have to remember in mind. A quadratic equation whose roots are alpha beta can be written as. What is the meaning of this? Quadratic equation is this: ax square plus bx plus c, and this equation can be written as a times x minus alpha into x minus beta. Students, as we know, ax square plus bx plus c is equal to a x minus alpha, x minus beta, and we can prove it also by taking any example. Now we are going to divide both sides by a. What will happen? It is x square plus b upon a times x plus c upon a is equal to x minus alpha, x minus beta. Now we are going to multiply these two brackets. It will become x square minus alpha plus beta times x plus alpha into beta. Now comparing these two sides, we can find that alpha plus beta is equal to minus b upon a, and alpha into beta is equal to c upon a. Students, one important thing is here, the condition that a quadratic function, what is the quadratic function? Expression which have the degree 2, and general quadratic expression is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c, may be resolved into two linear factors if delta is equal to 0. What is the meaning of delta? abc plus 2fgh minus af square minus bg square minus ch square, and this setup can be written into the determinant form like this: a, b, c, hgf here and hgf here is equal to 0. By this method, we can find that this general quadratic expression can be resolved into two linear factors. For that, the delta must be equal to 0. One important thing is here, if p plus iota q, where p and q real, is a root of a quadratic equation, where iota is equal to root of minus 1, then p minus iota q is also a roots of quadratic equation, provided all the coefficients are real. This is the important concept. Coefficient must be real, then we can say if one root is p plus iota q, then other root must be p minus iota q. Students, one important thing here, if p plus root q is an irrational roots of the quadratic equation, then p minus root q is also a roots of the quadratic equation, provided that all the coefficients are rational and q not being a perfect square. Students, remember one more thing, if the quadratic equation is satisfied by more than two distinct numbers, real or imaginary, then it become an identity. And as we know, what is the meaning of identity? An identity have infinite many solutions. That's why if a quadratic equation have more than two roots, means roots are greater than the number of degree, then this quadratic will convert into identity. And for that we can say a is equal to b is equal to c is equal to 0. Students, we are going to solve one illustration here. If alpha beta are the roots of the equation k times x square minus x plus 5 is equal to 0, and if k1 k2 are the two values of k for which the roots alpha beta are connected by the relation. What is the relation? Relation is here. Then find the value of k1 upon k2 plus k2 upon k1. Got it? Now we are going to simplify it. Taking LCM, it is the alpha square plus beta square upon alpha beta is equal to 4 upon 5. Alpha square plus beta square can be written as alpha plus beta whole square minus 4 alpha beta and it is whole upon what it is equal to alpha plus beta whole square minus 2 alpha beta whole upon alpha beta is equal to 4 upon 5. What is the nature of quadratic equation? It is kx square plus 1 minus k times x plus 5 is equal to 0. Sum of roots means alpha plus beta is equal to minus b upon a. It will be k minus 1 upon k, and product of the roots is 5 upon k. Now substitute the value of sum and product here. It will become k minus 1 whole square upon k square minus 2 alpha beta, it is 5 upon k whole upon 5 upon k is equal to 4 upon 5. Now we are going to simplify it. It is k minus 1 whole square minus 10k whole upon k square and whole upon 5 upon k is equal to 4 upon 5. Now simplify it. It is cancel out and 5 also cancel out, means k minus 1 whole square minus 10k is equal to 4. Now simplify it. It is k square plus 1 minus 2k minus 10k is equal to 4. It is k square minus 12k and it is minus 4, it is minus 3 is equal to 0. This equation provides the roots k1 and k2, and sum of the roots is 12 and product of the roots is minus 3. So we can find the value of k1 square plus k2 square upon k1 k2. It is equal to k1 plus k2 whole square minus 2k1 k2 upon k1 into k2. What is the value of k1 plus k2? It is 12. We simplify it. It is 12 square 144 minus 2 into minus 3 upon minus 3. Now simplify it. It is 144 plus 6 upon minus 3 is equal to 150 upon 3. It is equal to minus 50. So your answer, the value of this is minus 50. Students, now we are going to study sign of roots of quadratic equation. Sign of roots of quadratic equation: ax square plus bx plus c, where a is not equal to 0 and a, b, c are the real number. First condition is here. Condition for both roots are positive. Means roots are positive. Then roots are distinct or maybe equal. Then we can say d is greater than equal to 0, because for the distinct roots d is positive and for equal roots d is equal to 0. And as we know, both roots are positive, means sum of roots is also positive. So we can say minus b upon a is also positive. And if roots are positive, then product of the roots is also positive. So we can say c upon a is also positive. These three conditions are important condition for given system that both roots are positive. Students, second condition is here. Both roots are negative. If both roots are negative, then again d is greater than equal to 0. Okay. Roots are negative, then sum of the roots is negative, means minus b upon 2a is negative. And if both roots are negative, then product of roots is positive. So we can say c upon a is positive. Third number condition is here. Condition for both roots be of opposite sign, means let alpha is positive, then beta is negative, and if alpha is negative, then beta is positive. So we can say fundamentally that product of the roots is negative. What is the product of the root? C upon a. This is negative. Then we can say that AC means a into c. Product of a means coefficient of x square, and product of the constant term, it is negative, because this ratio is negative, means roots means a and c are of opposite sign. If A is positive, then C is negative. If C is negative, then A is positive. That's why we can say A into C is less than 0, or we can say C upon A is less than 0. Number 4, condition is here for both roots to be opposite sign and of equal magnitude. What is the meaning of this? Let alpha and beta, they are of opposite sign and having equal magnitude, means alpha is equal to alpha and beta is equal to minus alpha. Then what is the value of sum of the roots? It is 0. And as we know, the sum of the roots is minus b upon a. Then we can say b is equal to 0. Students, here are some practice problems you can check. For what value of k will this equation have roots equal in magnitude but opposite in sign? Means one root is alpha and other root is minus alpha. Then we can observe that sum of the root is 0. Now we are going to simplify it. This quadratic equation like this: x square minus bx times k plus 1 is equal to k minus 1 times ax minus c. Now we are going to simplify it. It is the k plus 1 times x square minus b times k plus 1 times x minus k times ax minus c and plus 1 times ax minus c is equal to 0. Now simplify it. K plus 1 x square minus the coefficient of x. We are going to collect the coefficient of x. From here it is the bk, and from here it is ak, and minus x is common, that's why. And from here x is common, minus x is common. Okay, keep in mind minus x is common, that's why it is minus a, and remaining portion is constant term. What is the value of constant term? From here it is the kc, and from here it is the c. And one thing remember, the coefficient of x, from here it is the minus b, means if minus is common, then it is the plus b also here. Plus there is a constant term equal to 0. Now we can say if sum of the root is 0, then bk plus ak plus b minus a whole upon k plus 1 should be 0. That's why we can find the value of k. A plus b is equal to a minus b. The value of k is a minus b upon a plus b. Student, let's see one example here. For what value of m the roots of equation be the reciprocals? What is the meaning of reciprocals? Means one root is alpha, then other root is 1 upon alpha. Then we can say the product of root is 1. So we are going to apply the product of root here. This is c upon a. What is the value of c upon a? It is minus 3 upon 8 m, and this is equal to 1. So we can simplify it. M is equal to minus 3 by 8. This is the value of m. Students, now we are going to study quadratic expression and its graphical representation. The expression ax square plus bx plus c is said to be a real quadratic expression in x where a, b, c are real and a is not equal to 0. Let fx equal to ax square plus bx plus c where a, b, c belongs to R, a is not equal to 0. Fx can be rewritten as like this. This is the making of perfect square. And if you write the fx like this, then it is the equation of parabola, where d is equal to b square minus 4ac is the discriminant of the quadratic expression. Therefore, y is equal to fx represent a parabola whose axis is parallel to the y-axis and having vertex minus b by 2a, comma minus d by 4a, means the representation like this. If a is positive, this a, got it? And if a is negative, then this is the downward parabola, and vertex is minus b by 2a, comma minus d by 4a in both the cases. Vertex is here and for this vertex is here. This is the graphical representation of quadratic expression. Students, one note is here. If a is positive, then the parabola will opening upward. Okay, if a is negative, then parabola will opening downward, and it depends on the sign of discriminant b square minus 4ac that the parabola cuts the x-axis at two distinct points, touch the x-axis and never intersect with the x-axis. This system gives rise to the following cases. Case number 1. If a is greater than 0 and d is less than 0. What is the meaning of d is less than 0? Roots are imaginary. If roots are imaginary, then there will be no intersection of the parabola and the x-axis, because if intersection, then there are real roots. For the real roots, discriminant is positive. Here discriminant is negative. That's why we are going to draw the diagram like this. Means there will be no intersection of the parabola and the x-axis. And in this case, fx is always positive. And in this case, the parabola always remains concave upward and above the x-axis. This is the one of the most important concept. We have to remember in mind that if fx is positive, then a is positive and d is negative. These are the two fundamental conditions for fx should be greater than 0. If fx is greater than 0, then we can write a is positive and d is negative. Point number 2. If a is positive and d is equal to 0, then we can say fx greater than or equal to 0 for x belongs to real number. D is equal to 0 means roots are equal. In this case, parabola touches the x-axis and remains concave upward because a is positive. This is the representation of the quadratic expression in the graphical manner. Point number 3 is here. If a is positive, means parabola opening upward, and b square minus 4ac is also positive, means there are real and distinct roots. Then fx is positive from minus infinite to alpha and from beta to infinite. Here fx is positive and fx is negative between the roots. And fx is equal to 0 at the point alpha and beta. In this case, the parabola cuts the x-axis at 2 points alpha and beta and remains concave upward because a is positive. Point number 4. If a is negative, then parabola is concave downward, and if d is negative, then we can say fx is always less than 0. In this case, the parabola remains concave downward and always below the x-axis. Point number 5. If a is less than 0 and d is equal to 0, then we can say fx is less than equal to 0. In this case, the parabola touches the x-axis and remains concave downward. Point number 6. If a is less than 0 and b square minus 4ac greater than 0, means there are two real and distinct roots, then graph of the parabola is like this. Then we can say fx is positive between the roots from alpha to beta and fx is negative from minus infinite to alpha union beta to infinite. In this case, the parabola cuts the x-axis at 2 points alpha beta and remains concave downward.